Hello, welcome back to another Keep Looking Up with the Word Feature Planetarium. I'm Tiffany Wilbrick, Planetarium Lecturer. Here with me is our Planetarium Engineer, Kurt Spivey.
Hey.
And our two student workers, Eleni Hunsick.
Hello.
And Nishan Adhikari.
Hello.
We're here tonight to celebrate Women's History Month and discuss women in astronomy, both past and present. But first, we're going to take a little look at the nighttime sky with Kurt. Happy Vernal Equinox. I think Kurt will talk about that a little bit more, but today's a special day. So I hope you enjoyed the beautiful weather today. If you're here in Ohio. I see we have a few viewers on right now. Let us know where you're watching from, and if you have any questions, please let us know in the Facebook chat. We will be happy to answer either live or on the comments. Thank you all. Kurt, you can take it over from here.
Well, very good. I will also echo happy vernal equinox, everyone. Spring officially started at 5:47 this morning. At that very minute was when the sun was directly over top of the equator. The word equinox means in Latin equal night. If you were right at the equator, you would have exactly 12 hours of daylight and 12 hours of darkness on this day. We're pretty close right now here, but because we are at such a northern latitude, that actually happens a few days after the equinox for us. But if you saw pictures, the sun is setting directly west and rising directly east the next couple of days, and our days will continue to get longer as we head for the summer solstice coming up in June. So, and very happily, I can look outside and there has not been a cloud in the sky the last 2 days. And I encourage you, if you get a chance, 3 days in a row, we're not going to have a single cloud in the nighttime sky. So all of those of you who bought telescopes at Christmas, now's the time. Get them out. It's time to go out and look up at the nighttime sky. And speaking of which, let's take a look at some of the things you can see if you go out to look at the nighttime sky. I'm going to, I don't need to share sound. I'm going to share my screen, and this is our program Stellarium, which is a free planetarium program you can find online to help you find things in the nighttime sky. I have set my Stellarium for 10 o'clock this evening. You need to do that because since the last time we were here, we had a time change and it's now getting dark later. There's a reason why I set this for this time, so I don't have to change times as the show goes on. Most of what I'm going to show you, you'll be able to see right after the sun goes down. Sun goes down around 7:30. You should be able to see some stuff in the nighttime sky by about 8 o'clock, including this right here. One thing that Stellarium does not do very good is the moon phase, but we do have the moon up. I was out for a walk this afternoon and saw this in the daytime sky without any clouds. You will be able to see it. We have a very fat crescent moon tonight. Tomorrow night is the first quarter moon when it will be half lit up. Now, why is it called a quarter moon when it's half lit up? Well, originally the word month was moonth, and the moon goes around the earth roughly every 28 days. I know it's not exactly, but to get from new moon to this first quarter is 7 days, or roughly 1/4 of the way through its cycle of phases. So hence the first quarter moon. I will actually zoom in on that so you can see that a little bit better, because it will turn into the quarter moon when you do that, but I'm going to pull back for now. We are looking to the northwestern sky. The sun went down directly west right here at 7:30 or so. Also up in the western sky right here is the planet Mars, and it's right next to the bright star Aldebaran and Taurus the bull. Last time we were here, Mars was right next to the Pleiades, which are right here. I will note that Mars and Aldebaran are almost the exact same color in the sky. Stellarium here makes Aldebaran a little paler than Mars, but they are about the same brightness and the same color. Still pretty easy to pick out, and that is a really good spot to hit with a telescope. Lots of good news coming back from Mars. The latest thing that NASA had up from Perseverance was they had an audio recording of it driving across the Martian landscape, which was very interesting to hear. It's dropped a protective panel off the bottom, so its sample collector pods are ready to go, and it's under there that the Perseverance, the Ingenuity helicopter is too. They're going to find a likely spot, put Ingenuity down, and get it ready to go here in the next few weeks as well. But we're here to talk about the nighttime sky. I'm going to come around to the northern sky. And as we look up there, N is right here. Over in this part of the sky, we have 3 stars that make a handle and 4 stars that make a cup. And for all my planetarium veterans out there, I'm sure you recognize that. That, of course, is the Big Dipper. And the Big Dipper is always up in this part of the sky and bright enough you can see it even when you're around light pollution. As a matter of fact, I am going to drop out light pollution like that so you can see the stars a little bit better. If you take the 2 stars at the end of the Big Dipper's cup and draw from the star at the bottom to the star at the top, follow that across the sky. The next bright star you come to is right there. That, of course, is Polaris, also known as the North Star. You can see it is directly above the N there. If you can find Polaris, it always points you north in the sky. But last time, Tiffany talked more about the winter sky. I'm going to bring us around here to the east, and there's a reason why I said it's for this time, because we are now into the spring sky when we look into the east, and by 10 o'clock, all the major players are up where you can see them in the nighttime sky. Now, the spring sky does not have the super bright stars or really easy to recognize constellations that the winter sky does. However, this is a good time to talk about the Big Dipper in the nighttime sky. The way we found the North Star is a very technical process we astronomers employ, known as a star hop. And all that is a fancy way of saying if you know how to find something like the Big Dipper, you can then use it to move around and find lots of other things in the nighttime sky. Well, as it turns out, the Big Dipper is the best thing that you can ever learn in the nighttime sky, because there are a bunch of star hops you can do off of the Big Dipper. It is a key that will unlock the entire night sky for you. And at no time of the year is it easier to use to find stuff than right now in the spring. For example, we can take these 2 stars at the back of the Big Dipper's cup, and we're going to reverse our line. We're going to draw a line from the star at the top of the cup through the one at the bottom. And when we do that, it's going to point to this bright star right over here, which is called Regulus. And you do have to say it with the rolled R if you want to be, no, I'm kidding. It's called Regulus. And we find Regulus in the very famous and very distinct constellation of Leo the Lion up in the nighttime sky. And I need to do that. So this is a little bit easier. Because I'm not right on it, it does that. Let me do this again. Stellarium is a free program, so it does have its little kinks. So there's Leo the Lion up in the nighttime sky as a line drawing. You can also picture him, though, as a big lion in the sky. Roar! And he is very easy to spot because his head looks like a backwards question mark. I just moved the sky on you. Let me bring that around a little bit more. A question mark in the sky that we call the sickle. That's what we refer to as an asterism. Looks like a backwards question mark up there in the sky. Now, Leo isn't the brightest constellation, but there just isn't a whole lot else around Leo in this part of the sky. So even around lights, he's very easy to pick out because of the sickle and Regulus in that constellation. You will notice this here says 4 Vesta. That's the 2nd largest asteroid in the asteroid belt. If you had a really good telescope, you might be able to spot that there. I unfortunately cannot turn that off because I have the planets turned on, but that is in Leo right now, which is kind of cool as well. So we used these two stars in the Big Dipper. We drew across and we found Polaris. We used these two stars in the Big Dipper. We drew down and we found Regulus. We can also do a star hop with the three stars we haven't used yet, the handle of the Big Dipper. Told you this thing's useful. What we're going to do is we're going to follow the curve of the handle or make an arc. And when we do that, we're going to hit this bright star right here, which is called Arcturus. And what we just did there is we arced to Arcturus. We astronomers are kind of absent-minded. We need these little things to remember these constellations. We find Arcturus in a constellation I have always had a bit of a problem with called Bootes the Herdsman. Now, I don't have a problem with this constellation because it's a dumb name. Actually, you can call him Booties if you want to. It's one of the dumbest names in the entire sky. No, my problem is I don't know any herdsmen, so I don't know what a herdsman is supposed to look like. So when I see Bootes, I usually picture something a bit more familiar. And for those of you who are here in the Youngstown area, I'm sure you will see this as well. There's Arcturus. That's the base of a cone right here. Here is a scoop of Handel's ice cream on that cone. And everybody knows how big Handel's makes their ice cream cone. The scoop has fallen off and is laying next to it right on the horizon over here. That's a little easier to see than a herdsman myself. By the way, the scoop that fell off, this is another constellation. It's a little constellation with a great big name. That little curve there is called Corona Borealis, or the Northern Crown. And according to the Greek people in one of their stories, Hercules was supposed to have thrown those stars up there a long time ago. Now, this is a very handy star hop because we don't have to stop with Arcturus. If you arc to Arcturus and then draw a straight line from there and make a spike, you're going to hit the third bright star of the spring sky right here. That star is called Spica. So you arc to Arcturus and then spike to Spica. And we find Spica in the very large but very dim constellation of Virgo the Maiden in the sky. Virgo is the second largest constellation area-wise in the entire sky. She starts all the way up here behind Leo and actually goes way down below the horizon. I will point out something to you, though. It is the first day of spring. You notice Spica is drawn in her hand as a chaff of wheat. Well, the nighttime sky was, the constellations were used for more than just remembering stars and doing the myths and things in the sky. Back when they created these things, they were also a calendar. People couldn't look at their cell phone or their wall calendar, tell what time of the year it was. They used the night sky for this purpose. And Spica here is a very important star because you'll notice it's just clearing the horizon at 10 o'clock, right after sunset. It's rising right at sunset on the first day of spring. So farmers would watch for Spica. When it's where it is now, they knew it was time to plant the crops. Spica will be in our evening sky all summer long, but it'll be coming up earlier and earlier and setting later and later. And when Spica set as the sun was setting, which happens about September, October, they knew it was time to harvest the crops. That's why it's drawn as a chaff of wheat there, to show it was a calendar in the nighttime sky as well. So those are a few things in the spring sky. I am not going to cover any more this evening because we have a lot to cover with, because there are a lot of fantastic women that both in the past and in the present in the world of astronomy. So I'm going to first turn you back over to Tiffany, who will then introduce, I guess Eleni goes first. So Eleni is going to be talking about some of the astronomers in the past of astronomy. So take it away, Eleni.
All right, thanks, Kurt. So hopefully you all can see my screen. And as Kurt mentioned, in celebration of Women's History Month, I'll be telling you all about some historical women who influenced the field of astronomy. And as Kurt said, there are a lot of women who have influenced astronomy, so I won't have time to talk about each one, but I will get to as many as I can. The first one I want to talk about is Caroline Herschel. She was born in Germany in 1750, and her mother did not see the need for her to become educated, and she encouraged her to become a house servant. However, Caroline's father encouraged her and all 5 of her siblings to study mathematics, French, and music. At the age of 10, Caroline was diagnosed with a disease that permanently affected her growth. Her parents concluded that she would never be successful because of this, so she lived with them until the age of 22 when her brother, William Herschel, moved to England and brought her along to be his housekeeper. William initially moved to England because he was an accomplished musician and conductor, and Caroline became a well-known singer there as well. The two built telescopes together as a hobby, and they were able to quit their jobs as musicians to devote their time to building more powerful telescopes and developing a mathematical approach to astronomy. In 1783, Caroline discovered 3 new nebulae, and nebulae is just plural for nebula, which is a cloud of gas and dust in space. Over time, gravity pulls the gas and dust in these nebulae together to form stars. One example of a nebula is the Orion Nebula. This is a very bright nebula that you can see in the sky. It wasn't discovered by the Herschels, but it's just a good example that I wanted to show you because you can see it on your own. The picture on the left is the Orion Nebula taken with the Hubble Space Telescope, and the picture on the right shows you that you can see the Orion Nebula. It just looks like a fuzzy spot in the sky just below Orion's belt. So I know it's spring and we can't see Orion anymore, but next time you can see Orion in the wintertime sky, you should definitely go out and see if you can see this because
Eleni, he is up in the evening sky right now for
up?
about an hour or two still. Yeah.
Okay, so right after the sun sets, go look for it. But anyway, Caroline also discovered several comets between 1789 and 1797, and in her later years, she cataloged every discovery that was made by her and her brother. 2 of her catalogs are still used today. She lived a long life until the age of 97. In 1828, the Royal Astronomical Society awarded her the Gold Medal of Science for her contributions to the field of astronomy. This award would not be received by another woman until 1996. The next female astronomer I want to talk about is Wang Zhenyi. Born in China in 1768 during the Qing dynasty, she had almost no legal rights, and education for women was very limited. However, in her short life of 29 years, she educated herself in astronomy, mathematics, medicine, and geography, and she also wrote poetry. She contributed to all of these fields through her 12 published books, many of which are used for the education of young scientists because she explains things in a unique way because she was self-taught. She was driven to demonstrate, model, and expand upon certain concepts in astronomy. She was particularly interested in eclipses, and she was able to simulate one using a spherical lamp to represent the sun, a mirror to represent the moon, and a round table to represent the earth. She was able to use this setup in addition to her knowledge of astronomical principles to produce the most accurate explanations of eclipses for the time. She recognized and described the relationship between the Earth, Moon, and Sun, and she was able to calculate their movement during events such as equinoxes, which Kurt mentioned. Today happens to be one of the equinoxes. Zhenyi's work contributed to future astronomical studies, and her poetry encouraged future equality and equal opportunity, as she was known for communicating the idea that men and women were all people who all have the same reason for studying. Next is Maria Mitchell. Maria Mitchell was born in Massachusetts in 1818. She was one of 10 children, and her parents advocated for equal education for girls. Upon completing her education at 16, Mitchell opened a school for training girls in math and science. Her father built an observatory, which she used to discover a comet in 1847, making her the first female astronomer in the United States of America, as well as the first American to discover a comet. And a comet is just a relatively small piece of rock and ice that orbits the sun at an extremely elliptical orbit. This means that comets spend most of their time far out beyond the outer planets of the solar system, but periodically they get closer to the sun. When they get close to the sun, the materials that make up the comet heat up and create a tail of gas and dust. Very few comets are visible from Earth without a telescope, but when they do get close enough, they're really cool to see. So if you ever hear that there's going to be a visible comet, I encourage you to go outside and try to see it. I think the last visible comet, at least to us, was Comet Neowise last summer, which was really cool to see. I hope some of you got to see it. If you did get to see it, let us know down in the comments. As Maria Mitchell developed her interest in astronomy, she became the first female astronomy professor. She won several awards, and she was eventually elected to the American Association for the Advancement of Science, where she was one of the first women to be employed by the United States government. She became involved in the anti-slavery movement and suffrage movements and defied social conventions by having her female students work on research that was published in journals, which normally only published work that was done by males. Some of her female students were even included in the official list of academic men in science. Mitchell formed and led several organizations for women in science until she retired in 1888 and passed away in 1889. Next is an astronomer who did very important work that is still used by almost every astronomer today. Annie Jump Cannon was born in Delaware in 1863. She was inspired to study astronomy by her mother, who enjoyed stargazing with her when she was very young. Though Cannon suffered from hearing loss at a very young age, she did not allow that to prevent her from achieving her goal of becoming an astronomer. She studied physics and astronomy in college and went on to become a junior physics teacher while taking graduate classes. She also enrolled in the astronomy program at Radcliffe College, which at the time was the college for women that was attached to the all-male Harvard College. She was hired to work as a computer at the Harvard Observatory. Computers were female astronomers who were responsible for classifying stars in the data taken by male scientists. During this time, Cannon developed a new and improved system for classifying stars based on their temperature and size. This system is called the Harvard Spectral Classification System, and it was adopted by the International Astronomical Union as the official system for star classification. It remains the official system to this day. Cannon was also well known for her ability to classify stars by hand extremely quickly. She classified over 350,000 stars in her lifetime. Cannon was also dedicated to fighting for women's rights and became the first woman to receive an honorary degree from Oxford University. She was finally awarded a faculty position at Harvard in 1938, and she worked in the Harvard Observatory until her death in 1941. And there are two other female astronomers who studied at Radcliffe shortly after Annie Jump Cannon, who also made very important discoveries: Henrietta Swan Leavitt and Cecilia Payne-Gaposchkin. Henrietta Leavitt also worked at the Harvard Observatory as a computer. She was responsible for discovering a lot of Cepheid variables, which are a specific type of star, and they periodically change in brightness. During her studies, she noticed something that no one had recognized before. The period of the change in brightness of a star was related to the star's magnitude or brightness. This discovery made it possible for the first time ever to calculate accurate distances of these stars from Earth. And these stars, called Cepheid variable stars, are still used for reference when measuring distances to astronomical objects, and this capability has led to many major astronomical discoveries. And then Cecilia Payne-Gaposchkin did not work as a computer, but she did complete her PhD at Radcliffe University in 1925. Her PhD thesis was about the composition of stars. Until this point, scientists thought that stars were made up of similar materials to what made up Earth's crust. Cecilia utilized her knowledge of chemistry to interpret data from stars and found that stars are largely made up of the two lightest elements, hydrogen and helium, not the heavier elements that make up the Earth's crust as scientists had previously thought. Many scientists were skeptical of this finding, so Cecilia downplayed her results as a possible error, but her results were informed by the past work of physicists and chemists, and future research proved that she was correct. This was a very important discovery in astrophysics because scientists could use this knowledge of the composition of stars to understand how they form and evolve. All right, now we're getting to some more recent women in astronomy. This is Katherine Johnson. She was born in 1918 in West Virginia. She excelled in mathematics at an early age, but none of the schools in her county offered public schooling for Black students past 8th grade. So her parents sent her to attend high school and college at West Virginia State College. She graduated with a degree in mathematics with the highest honors, and she began teaching in West Virginia. In 1939, West Virginia began integrating its graduate schools, and Katherine Johnson was the only woman out of 3 Black students who were offered spots at West Virginia University. She accepted the offer, but she left a semester later to return to teaching. In 1953, she pursued a job opportunity at a company now known as NASA in Virginia. She was very quickly offered a permanent position analyzing data from flight tests. In the late 50s and early 60s, Johnson did many of the important calculations and the analysis for early space missions, as she was trusted with important calculations because of her math skills. In 1962, Johnson was responsible for the calculations used for John Glenn's mission, where he would become the first American to orbit the Earth. In addition to all of the other manned space missions, because astronauts were afraid to put their lives in the hands of electronic machines. Catherine's job was to run all of the calculations by hand one last time as part of the pre-flight checklists, and they would only proceed with the missions when Katherine had checked all of the math. Katherine is best known for her life-saving work on the Apollo 13 mission in 1970. Apollo 13 was a manned mission to the moon, but an oxygen tank on the ship failed 2 days into the mission. The landing was aborted, and Katherine Johnson calculated a trajectory to get the astronauts back to Earth safely before they would run out of oxygen. The return was successful. Johnson retired in 1986, and she was awarded the Presidential Medal of Freedom, which is the highest civilian honor, in 2015. She lived to be 101 years old and died in 2020. Next is Nancy Grace Roman. She was born in 1925 in Tennessee, and she knew she wanted to be an astronomer since she was in 7th grade. She was discouraged from studying physics or astronomy because she was a woman, but she graduated with a bachelor's in astronomy in 1946 and a doctorate in 1949. She made important discoveries regarding the evolution of stars, but she knew that she wouldn't be able to get tenure as a woman in academia. She got a job with NASA in 1959 and served as Chief of Astronomy and Relativity. And mostly she managed astronomy programs and grants, and she knew that she would not be able to continue her research, but she was excited to contribute to programs that would help with the future of astronomy. Roman is best known for making the Hubble Space Telescope a reality by setting up a committee in the 1960s and convincing NASA as well as the US Congress that building this telescope should be a priority. Hubble is arguably the most scientifically revolutionary space telescope of all time, and Roman is now known as the mother of the Hubble. Roman passed away in 2018, and in 2020, NASA announced that they will name the Hubble Space Telescope's successor in her honor. The Nancy Grace Roman Space Telescope, pictured on the right, will be launched in the mid-2020s, and it will investigate current questions in astronomy, such as what is causing the expansion of the universe and what types of planets orbit other stars. Finally, our last historical female astronomer for today is Vera Rubin, who you may have already heard of if you've watched our pre-recorded Life of a Scientist series. Vera Rubin was born in Pennsylvania in 1928. She was interested in astronomy ever since she was a kid, and she spent a lot of time looking up the stars and building telescopes with her father. While her parents supported her in pursuing an education in science, her teachers discouraged her. But she was determined, and she obtained her master's and PhD in astronomy while she was raising her children. Rubin made a lot of important contributions to astrophysics, but her biggest contribution by far was her work on the theory of dark matter. Vera Rubin was interested in how galaxies rotate, and scientists had been modeling galaxies for decades based on trusted laws of physics like Newton's laws and Kepler's laws. They had determined that, based on our knowledge of physics, the stars and gas and dust closest to the middle of the galaxy should orbit the center very fast, and the stars in the galaxy should move slower and slower as you move farther and farther from the center. Rubin spent most of her time studying galaxies and taking data, and she found that this wasn't the case. She found that most of the material in galaxies was all moving at the same speed. Some scientists had observed this in a few galaxies before, but they attributed it to error, or they said that some galaxies might just be anomalies. Rubin proved that this was the case for all galaxies. But how could science be wrong? Why weren't galaxies behaving the way people expected? She was able to determine that in order for galaxies to behave this way, there must be matter that we can't see, much more matter than the stars and the gas and the dust we can detect, dark matter. Vera Rubin is credited with proving the theory of dark matter, though scientists to this day are still trying to figure out what it is and where it is, since we can't see it. They have some ideas, but that's a much more difficult question to answer. And we do have an old episode of Keep Looking Up that talks about dark matter, so if you're interested in that, you can check it out on our YouTube channel or back on our Facebook page. But Rubin is also known for advocating for women in science throughout her career. For example, when going to conferences, she would look at the list of speakers, and if there were very few or no women on the list, she would contact the organizers and tell them that they have a problem and they need to fix it. She also dismantled several men-only policies at various institutions, and she even advised the Pope to have more women on his committee. Vera Rubin passed away in 2016 at the age of 88. In 2019, NASA announced that they will be building an observatory in Chile called the Vera C. Rubin Observatory to honor her. This observatory will mainly be used to survey objects that can tell scientists more about dark matter and dark energy. So as you can see, there are a lot of awesome women who have made contributions to astronomy. And next, Tiffany's going to tell you about women who are currently doing astronomy. But before we move on, I wanted to see if anyone had any questions.
None have popped up yet, but James Thornton says Comet Neowise was a real treat.
Yeah, it was awesome. I'm glad people got to see it. But if there are no questions, then next, Tiffany is going to tell you all about what women are currently doing in astronomy.
Thank you, Eleni. Wonderful as always. There's so many wonderful women of astronomy throughout history. It's hard to choose. And, you know, I felt like I had the easy job of picking just from women who are currently alive. And even then it was still kind of difficult. But I picked just a handful. There was, of course, many that I did want to discuss, but we'll start here. The first woman that I wanted to discuss was Carolyn Porco. She is a planetary scientist who explores the outer solar system. She worked with Carl Sagan in the past on planning and imaging many of the planets with the Voyager missions, Jupiter, Saturn, Uranus, Neptune, including the famous blue dot photo. If you haven't seen that, you should Google it, the pale blue dot of Earth. It was the first image that we've taken of Earth from space. It absolutely, for many people, fundamentally shifted our, our understanding of where we are in the universe and who, what our place is in reference to everything else. Very stunning photo. She also led the imaging team for the Cassini missions, the Cassini mission to orbit Saturn. So she is really well known for her work with Saturn, first with the Voyager missions in the 80s, but now she is the leading expert in planetary rings on Saturn's moons. It's on Saturn and Saturn's moon Enceladus. One of her greatest discoveries so far was the giant geysers of icy particles on Enceladus. It indicated the presence of water on the Saturn's moon Enceladus. That was pretty big news. Sorry. Where did it? Another photo that she's famous for, this is called The Day the Earth Smiled. And it is sort of like a sequel to Pale Blue Dot, the first photo that we have of Earth. Look around and on this photo for just a moment. I'm not going to show you right away. Where do you think Earth is? Earth is in this photograph. And some of you might have seen this already, so you already know, but where is Earth? So Earth is, I hope you can see my cursor. I think you can. Earth is just underneath Saturn's rings, about the 4 o'clock position, this teeny tiny dot. You might not even be able to see it on your screen. So this is a photograph that Cassini took of Earth from Saturn, from orbit around Saturn. Truly beautiful. The next scientist that I wanted to talk about is Dr. Mae Jemison. She is an American astronaut and a medical doctor. She became the first Black woman enrolled in the NASA training program in 1987. And in 1992, she became the first Black woman in space on board the Endeavour mission. Jemison was the youngest child. Her father was a carpenter, and her mother was an elementary school teacher. And she was born in Decatur, Alabama, but they moved to Chicago at age 3 for better education opportunities for their children. Jemison said that her parents really encouraged her love of all aspects of science, but especially astronomy. That she received a lot of skepticism and people saying maybe you should be a nurse or maybe you should think about something else. She got a lot of that from her teachers and classmates, but her parents really encouraged her to pursue her dreams. She received a bachelor's degree in chemical engineering from Stanford, and then she went to medical school at Cornell, and she became a doctor. She worked as a doctor in LA and in the Peace Corps. She's traveled. She's done a lot of traveling. She did some studying in her schoolwork in Cuba and Kenya. She worked in Thailand's Cambodian refugee camp. And then when she was a doctor, through the Peace Corps, she worked in Sierra Leone and Liberia. But after all that, she came back to the US, 1985, changed her career completely, stopped being a doctor to apply to the NASA training program. So since then, she was an astronaut for a while, and then after that, she accepted a teaching fellowship in Dartmouth and founded the Jameson Group. It's a company that researches and develops advanced technologies. She is famously quoted for saying, "Don't let anyone rob you of your imagination, your creativity, or your curiosity. It's your place in the world. It's your life. Go on and do all you can with it and make it the life you want to live." Jameson is, I don't know if you can tell, but I'm a total fangirl. I love Dr. Mae Jemison. She's just amazing. I think that she embodies, not only breaking these barriers for being the first Black woman in space, but also the fact that she pursued a career and then changed her career, and she's really has made her life her own every step of the way. And I think that that's inspiring personally. She's also famously quoted in terms of when people ask her about being an astronaut. She says, "Once I got into space, I was feeling very comfortable in the universe. I felt like I had a right to be anywhere in this universe, that I belonged here just as much as any speck of stardust, any comet, any planet." I see Charles just commented. I'm gonna get there, Charles. So another reason why I really like Mae Jemison, she's also a Lego. I did not know that. That's wonderful. I have to go buy her Lego now. Mae Jemison also made her television debut on an episode of the Star Trek: The Next Generation. So she was a guest in one episode. So that leads me to my next person, who you might not at first glance consider a woman of astronomy, but I think I have deep respect for her, and I do absolutely consider her a woman of astronomy, Nicole Nichols. She starred in the original series, the original Star Trek series, as Lieutenant Uhura, who was 5th in command of the Starship Enterprise. So her character was a Black woman during the Civil Rights Movement, and she was number 5 in charge of this, at the time, world-class spaceship in this show. She also was part of the first interracial kiss on television, and so just her existing on the main the bridge is what they call it, but the main control console with the captain, with everyone, with all of the leaders on television during the Civil Rights Movement was a big deal. But Nicole Nichols really, TV wasn't originally what she wanted to do with her life. She was a singer and dancer, and that was really where her heart was. By age 16, she was one of the first African-American ballerinas. And her breakthrough on television, she just saw that sort of as a stepping stone to a long career in Broadway. That's where she really wanted to go. So much so that after the first season or so of Star Trek, she had told Gene Roddenberry, the creator of Star Trek, that she was going to leave the show, and so that she could pursue her dreams. And during some fancy Star Trek event, I don't know exactly what it was, but she was talking with some people, and someone came up to her and said, "Your biggest fan wants to meet you. You have to come this way." And she, assumed it was a Trekkie, and they brought her to Martin Luther King Jr. He was at the event, and he said, Miss Nichols, I am your greatest fan. Your show is the only show that me and my wife allow our kids to stay up late and watch on television. And they got to discussing. She was just, totally starstruck, and they were talking, and she admitted to him that she was planning on leaving the show. And she never even told him why. He cut her off and said, "No, you can't do that. You're a part of history." And so that's why she stayed. Nichelle Nichols took her career from sci-fi television to a career in science itself. So she leveraged her role as Lieutenant Uhura to form a company called Women in Motion to bring diversity to NASA. She is credited with recruiting more than 8,000 African American, Asian, and Latino women and men to the agency, paving the way for astronauts like Mae Jemison. So Mae Jemison accredits Lieutenant Uhura and Nichelle Nichols as inspiration for her decisions in her life, and Whoopi Goldberg has said that many times as well. The next scientist I wanted to talk about is Andrea Ghez. She is an American astronomer and professor at UCLA. Her research is focused on the center of our Milky Way galaxy. Her most notable discovery was in 1998. She and her team discovered a supermassive black hole that resides at the center of the Milky Way galaxy. Now, this was a really big deal because it answered one of astronomy's most important questions at the time. There was a lot of debate as to whether or not there was a black hole in the middle of our galaxy. There's still so much we don't know about galaxies, but it was through Andrea's work that we now know that most galaxies, at least of a reasonable size, do have black holes in their center, and we're not entirely sure why, but her work has led to that. Let's see. Ghez, she earned her bachelor's degree at MIT and her doctorate at Caltech, and she's been a member of the UCLA faculty since '94. And when she was young, she wanted to be the first woman to walk on the moon. Here is a photo of her work. So they detected her, Andrea Ghez and her team detected we call it Sagittarius A star. It's the black hole in the middle of our galaxy. They detected it through indirect methods. So they did not directly image the black hole, but they saw these stars that were orbiting around something of immense gravity. And so Ghez and her research team, they published this study that people have considered the most comprehensive test of Einstein's theory of relativity, of general relativity, because you have to, because something of massive gravity would have to be creating these orbits, right? So Ghez about this study says, Einstein's right, at least for now. She says that his theory is definitely showing vulnerability. At some point, we need to move beyond Einstein's theory to a more comprehensive theory of gravity that explains what a black hole is. So Einstein's theory of general relativity does not really explain what happens inside of a black hole. So she's sort of pushing those boundaries or those horizons and poking and prodding at the fundamental laws of physics. Pretty cool stuff. Among her future goals, Andrea Ghez has said that she wants to learn and test how gravity works near a supermassive black hole. So that's where her research is focusing now. Last October, Dr. Ghez won a Nobel Prize in Physics. Very well deserved. But she was becoming the fourth woman, only the fourth woman in physics to win the Nobel Prize in Physics. So Nobel Prize has been going on for 120 years, and there's only been 4 women that have ever won the Nobel Prize in Physics. The first was Marie Curie in 1903, Maria Mayer in 1963, and Donna Strickland in 2018. So this is a really great example of how there are systemic barriers in astronomy and physics, I guess physics in general, especially for women at all levels. And of course, this is something there are efforts being made to have this addressed, but it is a very long history of barriers for women and in science. So I want to really point out that Dr. Gez's Nobel Prize is very well deserved and earned, but it's not rare. There are many women in astronomy and in physics right now that are doing groundbreaking research, that are pushing the horizons of their fields and deserve this kind of recognition as well. So it's important to keep that in mind, that she represents a huge pool of women, that she's not out of the norm. This is not irregular just because she's the fourth woman to win the prize. She does share the prize with Reinhard Genzel of UC Berkeley. Oftentimes these discoveries take huge teams, so the Nobel Prize committee has to select just a handful of people to represent when they're providing these awards. The Nobel Committee praised Ghez and Genzel for their discovery of the supermassive compact object at the center of our galaxy. So that's why she won the award, is for the discovery of Sagittarius A star, the supermassive black hole in the center of our galaxy. And then the other half of the prize was awarded to Roger Penrose at Oxford for the discovery of the black hole formation as a robust prediction for the general theory of relativity. So Ghez is a prolific speaker, just like Carolyn Porco, the first woman I discussed. They're both very often in the media. And Ghez often encourages young students who love science and want to pursue their dreams, and encourages them to overcome obstacles. She says, follow your passions and be persistent. Find comfort with the discomfort. I find those to be very wise words. So that's what I have. I'm not seeing any questions. Oh, no worries, Charles. I'm glad you read my mind about the Star Trek. You know I have to talk about Star Trek if I get a reason to.
To geek out for those who come to the planetarium, you should have done the Andrea Ghez thing in a Liam Neeson accent. Just saying.
Don't do accents, but yes, we have a show that's narrated by Andrea Ghez.
No, narrated by Liam Neeson with Andrea Ghez.
Oh yeah, that's right. She's interviewed in the show. You got it. Yeah. Maybe we can put that on our fall schedule. We're hoping to open back up in the fall to the public. We're in discussions about that now. We don't have any concrete news, sorry, but we will definitely let you know as soon as we do. I'm not seeing any more questions, so we'll wrap up here soon. But if you guys have any other questions or comments, feel free to continue the discussion in the comment section on Facebook. We also upload these to YouTube, so you can watch them later. And Kurt, do you want to talk a little bit about our next Keep Looking Up?
Our next Keep Looking Up is going to be April 4th, and you're going to get a whole lot of me with that one. I was talking about the constellation Bootes, which is a Latin name. The constellation itself is Greek, and then the star Arcturus is named by an Arabic gentleman named Al-Sufi. Now, how did we end up with all this interesting stuff? Well, astronomy is really fascinating because it's both cutting edge, as you just found out with Professor Gez, and it's also the oldest science. And we have a lot of traditions and nomenclature that comes from these things. So we'll be talking about where astronomy came from, why we have, we're going to focus on a lot of the terms we use today, why we have Latin names on Greek constellations and star names in Arabic. With our show, I can't remember what we decided to call it. We were discussing this Thursday and we can't remember what we had this nice alliterative name for it. I did a full dome show a few years ago called What Are Constellations, but that's rather blah. So we're going to have a nice title, but watch for it on our Facebook feed. We'll post that event here shortly.
Yes, I'm looking forward to this show. The history behind how we name things and why we call stars and constellations what we do is actually, it's really interesting. At least I think it is. So find out more about that on our next Keep Looking Up. I think that's April 3rd. It's 2 Saturdays from now, 2 weeks from now.
Is it the 3rd or the 4th? I don't remember.
One of those, whichever one's Saturday.
Yeah.
Well, and until then, thank you all, and remember to keep looking up.